All right, let's get rolling. So just a heads up, and somebody remind me maybe the middle of next week if I haven't handed them out yet. We have a present for everybody in class, but you're required to wear it to class every single time you come to class. Now you get to imagine what that might be. It's not like a shirt or something. It's something else you wear that's not overly cumbersome. Blindfold. But now I'll just let you imagine what that might be. So it'll be some fun. All right, but it's something that you'll use throughout the 4 years in our program, and it might get upgraded over time depending on your skill level. Okay, so last time we were talking about the evolution of our programming languages, right? And we were focusing with our web languages over here on the left, right? And we talked about how web servers work and this kind of jazz. And we said, no, we have our old networking model, client server model, which can be applied to all sorts of different things in computer science. Specifically in the web world, we'll have a web client and a web server, which is a fancy name for our web browser like Chrome, and whatever server software is running on a computer somewhere like Apache or Internet Information Server. Over here on the left-hand side, this is what we would call a client side or a front-end developer. So if you went and got a job as one of these people, you'd be writing some front-end JavaScript stuff as well as HTML and CSS and making things look pretty. If you're over here on this side as a server side or a back-end developer, you'll be writing a lot more programming-esque stuff. And the languages that you might use over on this side of things are going to be some of the languages we see here, like PHP. Ruby on Rails is a technology. I'm not going to go too deep into that. You'll see that in another class. We're looking at Python here, although Python is starting to bridge the gap. If we said, we were working with Python in this class, and even though Python kind of got its early start, let's say, in the web development world, it is commonly now used for machine learning, artificial intelligence stuff, data science, data analytics, business analytics. So it's a tool used in industry for things well beyond web. All right, so it's going to be a skill set that will be beneficial to you. And like I said, if you do a Google search for best programming languages, your top 5 is certainly going to have Python. Actually, your top 2 will probably have Python in it. They flip-flop between maybe Python and Java. Then it rounds out with C++, C Sharp, and maybe C's in there. Maybe, who knows? There's languages you've heard of. Even if you haven't had programming before, there are languages you've probably been exposed to. Okay, so we talked a little bit about computer protocols. So these are, a fancy way of saying the languages that different things speak to each other. We're all speaking the English protocol right now. The web server, this guy right here, he speaks a protocol called HTTP, Hypertext Transport Protocol. Even though we're not dealing with networking necessarily in here, later on in the class, we're going to be dealing with something called web scraping, where we'll be taking instead of hitting a website and viewing the contents inside of a web browser, we'll be having our Python program grab the HTML from a web page, which if we look at a random web page here, I just do view page source, we have wall of stuff, right? Now this is that wall of stuff right here, and that's what the web browser translates it into, pretty pictures and text, right? Well, sometimes, for example, let me just go to maybe finance.google.com. You might have a page like this. We'll go to Apple stock price. So a page like this that is showing the current stock price of Apple, and if we look at the page source for this, somewhere in here there'll be that $316 number for the current price of Apple, right? We might write a program that goes through all of this wall of text and extracts those 2 or 3 pieces of information that we might be interested in maybe showing on the screen on our Android application or something like that. Make some sense? Okay, so we'll be using the HTTP protocol to make that request to ask, in this case, Google's web server for the source code of this page that we will then process with Python, rather than have a web browser show it in pretty text. All right, so the good news is we won't have to learn HTTP in order to do this, because there's already libraries in Python that say open up web page, and it speaks HTTP for us. All right. So we talked about these technologies, Ajax, jQuery, Angular, React, and decided that these were the guys that allow certain pieces of a web page to reload on their own. And they're actually all just JavaScript libraries. All right, so these aren't actually different technologies in and of themselves. They're just specialized libraries to let you do fancy stuff in JavaScript that runs in the web browser. All right, remember we talked about 100% of programs that come out of a web server, whether it's just plain HTML where we can just serve that directly, or it's a computer program like a PHP program or a Python program that the web server has to execute, it will ultimately output HTML, CSS, and JavaScript. But collections of functions, yep. So the real life example, you can go to Target and buy a silverware library that comes with a bunch of forks and spoons and knives and things like that. Now you have access to those tools to do stuff. But that just gives you a lot of duplicates, but same difference. All right, but ultimately, whatever type of thing is being requested over here on the web server will either just, export the HTML from this document, or it'll run this PHP program or run this Python program, which will ultimately produce HTML, CSS, and JavaScript. Keep in mind that Python program had to be written with that goal in mind. We're going to be writing Python programs in here that are not going to be generating HTML, CSS, and JavaScript. We're going to be writing ones that are going to show some stuff to the screen and maybe, loop through strings, do some algorithm manipulation stuff, things that are meant for maybe human eyes to just kind of, run through a stupid looking program, not necessarily for a web browser to process it and turn it into pretty pictures and text. But if we wanted to play the game of having the Python language support a dynamic web page, we would have to write our Python program with the idea that its ultimate goal is to spit out output in this format, HTML, CSS, and JavaScript, because that's what this guy, the consumer of the output of that program, needs. That make sense? All right, so we get to choose as the programmer what the output of our program is going to look like, and if we want that to be compatible with a web browser, we need to spit out a format that it understands. All right, so at the end of class last time, I left us at this thing called Node.js. Node.js is a pretty interesting thing. It's relatively new, and it brings these two sides together. So I mentioned last time that a lot of times the folks here on the server side or the back-end development, they consider themselves real programmers and they kind of look down on the folks over here. Where I might argue that the folks over here are much more rounded technology individuals who are actually pretty good at making things look good and actually can program as well. Now, their programming skill set is going to probably be wider, right? You might have some folks that barely dabble in programming. They're mostly designers. And then you might have other folks that are actually really well versed in programming who actually happen to be able to do some design as well. And then everything in the middle. Well, maybe those folks that like programming, have quite a bit of programming background, but kind of grew up in this side of the world where they started maybe as a designer and then kept gaining their programming skills. They might be frustrated by the back-end developers over here who maybe are taking too long to get them the server-side piece for them to test their front-end website. You have a username, password, login thing, and you hit the submit button. These folks over here can design that page, and when you hit the submit button, it's sending a request over here. Now they're reliant on these people to write the code that receives that request and processes the username and password and decides, is this person legit or not, right? And if they're having to wait for this person over here to write that code, which is not complex code, right? There might be some really hard programs somewhere that maybe they do need to rely on one of these people to do that, but for, let's call it 90% of the stuff you're going to do in server-side web programming, it's effectively grunt work. It's the same type of thing. Today you did a paper on SQL, right? What is SQL? Okay, what do we use it for? What's the purpose? Okay, so it's a language, it's a protocol we use to speak to a database, right? And it allows us to ask a database. So we'll talk about databases more, but a database is a collection of data. Let's just leave it at that for now, okay? And SQL is a language specifically designed to ask a database management system which manages this collection of data. It's a tool specifically designed to say, give me information that meets this criteria. So, give me the record where the username is equal to this and the password is equal to this. Not that storing plain text passwords is a great idea, but let's just assume that's the case right now, since that's the example I'm using. And if it gives us a record back, that means, this person must be authenticated. If it doesn't, that means they either gave us a bad username and or password, right? Person's not in the system, right? That's not how modern authentication would actually work, but it's a simple enough example for what we're doing right now. So the idea is that this back-end program would use SQL to hit some database that's sitting someplace else and ask it for some information. And then take that information, maybe turn it into some pretty HTML and CSS and JavaScript, and send that result back over the internet for the web browser to process. Okay, that's where your SQL thing maybe fits in this world. So we might put a database management system, DBMS, up here, and maybe this our program over here talks to those guys, and that communication is going to happen via SQL. That make sense? That's where SQL fits in this world of development. We have this other tool that's sitting outside of the web server, outside of the web browser. This is going to be more on that server side. So whether it's living on the same physical computer as the web server, or if it's sitting on another computer, either in the same warehouse or somewhere else on the internet, this program might use SQL to open up a connection. Well, to query this database, like opening the connection uses another tool, but let's just assume we somehow magically have opened up this connection between our program and this database management system, and we're going to use SQL to talk to it. Right? That's where that tool comes in. Anybody know some examples of database management systems, DBMSs? MySQL? How many of you heard of that one? MSQL, Microsoft SQL Server. Now here's, how many of you have heard of the company called Oracle? What does Oracle make? Besides put their name on basketball stadiums. Okay, well, yeah, they own Java now because we're going to be talking about that we'll start it today at least. Yeah, they own Java because they acquired a company called Sun Microsystems years ago. It's funny. Oracle is one of these like secret companies that people have heard of Oracle. You've seen their logo all over the place and stuff like that. But we don't know what they make. Oracle makes a database management system called Oracle. That's their flagship product. In fact, it's widely known to be the fastest enterprise level database management system. Amazon uses Oracle. It's really expensive too. And actually they have a program, we do use Oracle some in our database classes because they have a free education license where we can teach Oracle for free. That way, when you go out into the wild and go work for a business, you then convince your boss, well, I know Oracle, go give them a bunch of money to run Oracle here. So Oracle would be another example of a database management system. But all of these guys would be SQL compliant. They all understand that SQL language. All right? So that's one of our little punchlines in technology that, in technology we have all these words, whether it's, things like Ajax, jQuery, Angular, that mean simple things, or even the names of companies, and we have no idea what the heck they make. But this guy makes database management systems. That's his thing. Okay. So, let's go back here. Actually, I want to stay here for a second. So what's the idea here? We're talking about the programmer over here, the more programming-centric person over here being frustrated they have to wait for certain things from these folks, and when they might be capable of writing some of this stuff. One of their issues, if they grew up, let's say, in this world, they didn't necessarily maybe come to school for computer science and learn a bunch of languages and learn programming. They kind of learned programming accidentally through their job. They went to school to be a designer, or something like that, graphic artist, multimedia design, and then they picked up programming. Chances are, if they're working in this world right here, the language they're familiar with is JavaScript. So among everything else we might say, what does Node.js do? It lets you write back-end programs using JavaScript. So now we have the same language on the back end as you have on the front end. Where in these pictures over here, you would have HTML, CSS, JavaScript over on this side, and you'd have either PHP or Python or Ruby or some other programming language over here on the server side stuff. Now, I've advertised that the language doesn't matter. Okay, so when you've learned computer programming from the perspective that programming is a skill set, the language doesn't matter. But if you've only been introduced to programming from, I know how to use this very specific tool, not that you can't go and learn Python or PHP, you might be most comfortable making that initial jump if the language you're working with is the same language. Make sense? Among other things, that's what Node.js brought to the table. It also has some real-time streaming stuff and upgraded stuff to what some of these other things have, but we're going to say that the most important thing from our perspective is it allows you to write JavaScript on both sides. Okay, so that pretty much gets us through all the stuff over here. So now we want to go through this storyline, and we're going to try to do that in less than 2 classes. So we can get to, so today and hopefully get through it on Monday so we can start, that's when our next papers due, so we can start focusing on the Python stuff. All right, so let's talk about the C programming language. All right, C came out in roughly 1968 and was created for writing operating systems. All right, that's what C is made for. It's something called a procedural programming language. Now I'm going to create another slide here. There are 3 kinds of programming languages. And one of them we're going to kind of ignore for right now. So I'll just throw it out there first. We're going to say we have functional languages. Functional languages are, for instance, if you've had a Texas Instrument graphic calculator, the programming language on there is a functional language where you have a function that calls another function that calls another function that ultimately boils down to a value. We use one in our 470 programming language theory class where we write a programming language. So we actually use a functional programming language to create a language kind of like Python. So for right now, let's just pretend like that doesn't exist. It's not really related to this class. Then we have procedural languages. These are monolithic in nature and tend to just be a single page of logic. So do this, then this, then this, then this, then this. Not that you can't have multiple files, but I'm going to kind of give you an example here in a minute that'll give you the difference between procedural and object-oriented. The last one here is object-oriented languages. So, much more organized, separates code into multiple, we're going to say modules. Now remember, somewhere up here, I probably said, what's the job of a programming language? Well, we probably said it out loud. Let's just throw it on a slide. So programming language is a tool that allows us to tell a computer what to do. All right? That's the high-level definition of a programming language. Now, ultimately, computers speak zeros and ones, binary, right? And we're going to talk about that in a lot of detail in this class as well. We don't. And we don't want that little two-button keyboard where we're just tapping out zeros and ones all day. Okay, so we expect these programming languages to benefit us, right? And now in real life, if you're working with a friend and you're trying to compromise, the idea is you might meet each other halfway, right? Each person kind of gets a little bit of what they want. Yeah, we're greedy as humans, and we don't really care about the computer's feelings. We're not interested in meeting the computer halfway. We want the language to benefit us 99.9% of the time. And the computer can just deal with the hardship, right? So we want our programming languages to allow us to solve problems in as similar a way as we already solve them in real life. We're already professional problem solvers in real life. We're already used to solving problems all the time. We talked earlier this week about how the problem with us, what makes programming difficult is that we're so good at solving problems that we can't articulate how we solve them. So we don't want to have to get stretched too far away from our comfort zone. I've already said that programming is going to be difficult because we're going to have to slow our mind down and think about those little tiny baby steps. But we don't want to go too far away from the way we already think about things. We don't want to be the folks that are out there at the mall just talking in zeros and ones. People are going to start, well, you probably get free food out of that, I'm guessing. We want to solve problems. We don't want to stop being human, right? We want to still be able to interact with our friends, interact with human beings. But now we're trying to talk to a computer. So we want this guy to let us solve problems in a similar of a way as we already solve problems in real life. So we go back to C, being a procedural language. 1968, how powerful were our computers compared to our computers today? Not very powerful, right? Computers today probably faster than what we had in 1968. More memory, faster processors, better everything. Okay? So do you think in the very early days, human beings solved problems in terms of how well we understand the tool? We've already talked about this. Whenever we have a problem we need to solve, we have to think about what tools we have available to us. You see these survivor shows on TV when you got somebody out in the wild. And they have to stay alive or something like that. And all they have is their wits and their senses, right? Okay, so, if you're thinking about, I don't have any tools available to me, all I have is my hands, you have to start thinking about how am I going to solve problems in terms of what's around me in my environment and what I'm able to do myself, right? Those are the tools we have available to us, and that's how we're going to solve those problems. Might not be ideal. We might wish we had a whole bunch of concrete and some forklifts and things like that so we can build a nice warm house, and we need electricity and running water, of course, but we don't have all that. We're out in the wild. We're stuck with solving the problem with the tools we have. Now, in the early days of computing, as personal computers were just becoming a thing, which is not in 1968, this was in let's call it the 80s, in 1968, computers were in the industry, big, rich companies that could afford having a computer to automate tasks like NASA, things like that. There's a good movie, what's it called? The women at NASA getting used to running the IBM mainframe that was there. I can't remember the name of the movie. Hidden Figures. Hidden Figures is the name of the movie. Great movie. It really talks about that transition. It also talks about some other diversity issues and things like that, but which is probably the more important message from the movie. But it also talks about this group of women who were mathematicians at NASA, and then they get these computing machinery, and the rocket scientists couldn't figure out how to use it. But these mathematicians, these women who were mathematicians, went in there and they figured out how to program the mainframe. And all of a sudden you have these folks learning how that tool can then be applied to making sure we don't miss the moon, that type of thing, rather than having somebody sit there and scribble out math formulas to get the exact number so that you don't miss the moon. Let's leave it at that. But good movie, definitely worth watching. But in the early days of computing, our computers were far less powerful than they are today. So even if we understood that tool, it's this new thing that you just got access to, right? And you have to start thinking, what can I use this for? So the types of problems we were solving with those early computers, using, let's just say for our example here, using the C programming language, was probably fairly primitive, right? Because our imagination, the juices hadn't started flowing yet. We just started solving the obvious problems that we might want to solve with computing. Do math fast, something like that. We've seen modern day examples of this. How many of you are iPhone users in here? Okay, well actually today it doesn't matter if you're iPhone or Android. So the rest of you are Android? All right, so kind of half and half. That's the usual case. At some point we're going to talk about that war as well. But about, I guess what it had been, 11 years ago, Apple came out with the App Store, right? How many of you have some kind of mobile app on your phone? Probably a whole bunch of them, right? Okay, you rely on, there's an app for that. You do your, I deposit checks using an app now, right? Well, when Apple first came out with the App Store, it was a toy. They invented a platform and said, millions of developers out there, tell us what you can do with this device, because our imagination is only going to let us come up with so much, right? So that's kind of like the early days of computing, where you have this mobile phone, it's in people's pockets. You have constraints like battery life and the screen size and things like that, and now they're asking the masses who know how to program to say, come up with solutions that leverage this tool to help us make our lives easier. And that's why they came out with the Fart app. Right? Remember the original app that you push the button and it makes different fart sounds? Yeah, Apple finally banned that one. But, so there's a lot of frivolous apps out there, but then there's apps that actually do real stuff, right? Banking, checking your email, all sorts of things like this. All right, but it took that army of developers to get those creative juices flowing to get these applications to our phone that leverage the fact that we had this thing in our pocket. Go back to the early days of computing, it took the same type of thing. Here's the tool, here's the computer that crunches numbers. Go and figure out what else you can do with it, or how can you leverage the fact that it can do math really fast to solve bigger problems, okay? So in the early days of computing, a language like C was not a problem. C is still a popular language today. It's really fast, it runs right on the hardware. In one of the classes, you're going to talk more about C. We use C in our operating systems class. But the idea is that we didn't start hitting limitations of C. The fact that C was a procedural language, which we'll clear that up here in a minute, wasn't a problem early on. Because remember, again, the point we're making here is that languages have to allow us to solve problems in ways that are similar to how we already solve them. We were already solving math problems, like writing out formulas and things like that, and C let us do that very easily, no problem, okay? All of a sudden, as the types of problems we were trying to solve became more and more complex, things got a little messier. The code went from this size to this size to this size to thousands and thousands and thousands of lines of code. And organizing it or debugging it or making updates to it became very, very cumbersome. Now we think about the way we solve problems in real life. How many of you ever been yelled at for not cleaning up your room? I think some of you are lying. All right, so we go into our house or go into the room, we just start throwing stuff places, right? It starts with one little pile, like, oh, I'm in a rush, I'm going to do something. And then we start just having stuff all over the place, right? Some of you might have current roommates that do that. Wait till mid-semester, that'll start a fight. But in any case, when you start organizing things, you think about, oh, what drawer can I put this into? Maybe you get a container and you put a label on it and this is my tax documents. Whatever. So we think about solving our world's problems or solving problems in our daily lives in terms of how we can organize these things. Even the most unorganized of us have some level of organization in our problem-solving tool set, even if we choose not to use it as efficiently as we could, right? All right, so what object-oriented languages gave us is a set of tools to allow us to organize our code. The difference between a procedural language and an object-oriented language is effectively Tupperware. Now let me give you an example of this. Procedural versus object-oriented phone. Okay, we're going to go a little old school here with this, but you walk into the classroom, and I have this big pile of wires sitting up here. And I tell you this is a telephone. First of all, you're going to all think that that's not a telephone, it's a pile of wires, that's a mess, get it out of here, right? Now you come up and investigate it a little bit more. You find the handset, and you find some buttons, you listen to it, you hear a dial tone as if those exist anymore, right? I think we're all of the age now we've heard a dial tone at some point. Yeah, but fast forward a couple of years, I'm not going to have students who've heard dial tones. It's going to be a thing. But eventually, I convince you that this pile of wires is, in fact, a telephone. Now, this is a phone, right? It does a bunch of other stuff. Let's just assume this is a telephone. How do you know this is a phone? Because of the way it looks, right? Do you believe that inside of this is the equivalent of that big pile of wires? All that stuff is inside of here, right? But when you use a telephone, you only need the part where you hold it up to your ear and the microphone that you can talk into and the buttons to dial the number, right? You only need those parts. Those are the public interfaces of the telephone that, as a human being, once this tool is produced, those are the parts of it that we have to interface with, that we have to interact with. All those details in here we appreciate, but we don't need to see those, right? If we really need to get at them, we can crack this guy open and start, replacing batteries and doing things like that. But those details are hidden inside because they're really important to the functionality of this, but they're not important to how we use it on a daily basis, how we use this object. All right, so this is a telephone object that has all those details, but they're neatly packed inside of this guy. Whereas that procedural telephone I had up here had all the same abilities as that guy, but not nearly as organized. We didn't create a nice little box and shove all the wires in there and then poke little holes for the parts of it that we need to actually interface with. Make sense? That's the difference between a procedural telephone and an object-oriented telephone. That's the difference between a procedural programming language and an object-oriented programming language. The object-oriented programming language gives us a set of Tupperware, boxes, drawers, whatever you want to think about, that allows us to shove the details that are really important, that needed to be written correctly the first time, but kind of hide them away in a way that, hey, we can get to them, but then it gives us the ability to access only the public interfaces of it that we actually need to solve our daily problems. That make sense? It's how human beings solve problems already. It's an organizational tool. All right. Procedural is pile of wires. Object-oriented looks like a phone, but we know the pile of wires is inside somewhere. In real life, we solve problems in terms of objects, right? We think about, I'm going to pick up a stapler, I'm going to grab my laptop, I'm going to grab my phone. Every object has a bunch of abilities that it can perform, right? If you're going to eat lunch, you're not going to well, you probably will grab your phone so you have something to entertain you during lunch, but if you're actually feeding yourself, you're not grabbing your phone and scooping the food into your mouth. Hopefully you're not, Well, we're going to see a couple of jokesters at the cafeteria today doing that. Okay. Instead, you grab the right tool for the job. You get a fork, you get a spoon, you get a whatever. All right. Go ahead.
Some of the people when they make smart forks that make coffee cups.
Well, they already have some tools. So, like, I have a bad tremor in my left arm. So, I think, well, actually, I don't think I told. So, I have a form of autism called Asperger's syndrome, and I've had it since I was like 9. And usually I kind of embraced my weirdness. That's why I'm a little quirky. But, you know, I'm on some pretty good drugs for that. I've been on it for years and years and years. And one of the side effects of it is my left hand shakes quite a bit. So, like, if I, hold my coffee, I start bringing it up here, it's going pretty good. And I have to usually keep lids on things. Otherwise, you get some spillage. I don't have any pain from it, but sometimes you start spilling food starts flipping off of here. My right arm's just fine. I could probably do surgery with this one. But in any case, they actually have like eating utensils, whether it's a fork or spoon, I don't know what it is, but made for people with tremors. So I think it's kind of was driven by like Parkinson's disease or something like that, so you're not flicking stuff around. It bobs and weaves with you, so the fork stays stable. It's kind of like those cereal bowls for the kids that are on so the kid, doesn't matter which way the kid's turning it, the bowl stays upright so they're not spilling cereal and milk all over the place, or even the snacks. Yeah, see, we solve all sorts of problems. Well, let's not fix the kid holding the cereal upside down. We'll just make it that's okay. And then all of a sudden you have the 22-year-old in the cafeteria doing the same thing. All right. So, difference between procedural and object-oriented. The way we solve problems in real life is in terms of objects because we like to make things convenient for us, right? And as the problems we started solving in real life became more and more and more complex, we started seeing some of the chinks in the armor of C. Not that it's not a great language, and like I said, not that it's not still used today. As you might imagine, the underlying operating system on our computers are pretty complex things where those wires are exposed most of the time. So C is kind of a great language for that. Plus, you have a whole history of stuff already written in C that we leverage in today's computing. So I don't want to advertise that C is an antiquated language. It's probably still in our top 5, certainly in the top 10 languages that's used today. But it's not the language that we might use for writing an iPhone app or an Android app or a business application. It's made for writing things that are not necessarily for direct human consumption. It's running a lot closer to the hardware, and those wires are more exposed. So as we started solving more and more user applications, business applications with our programming languages, we started seeing some weaknesses in C that, I really need to clean this code up a little bit. I need to organize it. Otherwise, the programmer down the, across the office who's going to be taking this project over is not going to be able to find stuff in here, right? Hence the birth of object-oriented languages that allowed us to organize things. We got some other upgrades, just like we talked about with Node.js or any of these other web technologies. As they got better and better and better, we added some new features and things that allowed us to solve problems more easily. So our object-oriented languages do have some evolutions like that, but largely the difference is organization, right? Nothing more. So that's where we make this jump from C to C++. So C++ is the object-oriented version of C. Still using C syntax. Largely C syntax. A couple little bobs and weaves here and there, but if you look at a C program and then you look at a C++ program, they got way more in common than they have than they're different from each other. Now, if we go up to this chart here, you see that so we have procedural up here. Oop. Still not working? There we go. We got our procedural language C here, and then we have our object-oriented programming languages here. So notice that C++ and Objective-C are separated here. How many of you have heard of Objective-C? Fewer of you, I'm going to guess. How many of you have heard of C++, at least in passing? A lot more of you. Okay. Anybody know why? Why have we heard of C++ and not Objective-C? I'm going to attach a couple of words to these, a couple of company names. Microsoft. Apple. Those companies don't necessarily like each other, right? Especially when you go back to their history, they really hated each other, even though they were partners for a long time, right? So if we think about Apple, Apple and Microsoft, and there's several movies out there that tell this story, so I'm not going to go into crazy detail, but I'll give you a couple of the highlights. Let's just talk about Microsoft first. All right, so Microsoft, famous company, right? Bill Gates guy. So here, we'll just throw Bill Gates on this guy. So we have Bill Gates, famous Microsoft thing. So back then, in the early days of personal computers, so let's call it the, early 80s, something like that, late 70s, early 80s, the cool kid in the computing world was IBM. We've heard of IBM? Okay, they're still around today. Now you see the commercials for IBM Watson. That's their artificial intelligence, machine learning thing. He also made a stint on Jeopardy. So that's kind of where things are going now with business analytics, business decisions being made by artificial intelligences. That's what Watson is. But back then, IBM was the cool kid. Well, famous, probably we might even say the most profitable meeting in history. Bill Gates and other Microsoft guys go in to meet with IBM. This is in the very early days of personal computers. And they, and of course, IBM being a hardware company, they, like I said, they had the IBM mainframe at NASA from that Hidden Figures movie, right? So they were very much a part of the computing world at the enterprise level. Now they're looking at getting into the, at the time, we'll call it the hobbyist level, because it wasn't necessarily something that we said was a necessity for everybody's home or business, but they wanted to be part of that thing. But we weren't sure if that was going anywhere. At the point in time, they're like, well, are computers really necessary for normal folks? Who knows? So, they didn't want to take too big of a risk. Well, Microsoft went in. I'm going to call this software licensing. So the biggest thing that Microsoft kind of brought to the table is the idea of software licensing. So they go into this meeting, and Microsoft said, look, you need our operating system to drive your hardware. And IBM's like, okay, tell me more. Because they're at that point in time, they're thinking, well, you know what, we already deal with hardware, and we don't know if our computers are going to sell, so we don't necessarily want to spend a fortune on software, on your operating system. And Bill Gates said, no problem. We'll license it to you on a machine-by-machine basis. If you sell an IBM computer, then you pay us for that one copy of our operating system. Make sense? Sound like a pretty good deal to IBM? Yeah, famous quote was, no problem, real money's in the hardware. Haha. Yeah. Hardware's cheap, software makes the money. That's why you need the superpower of programming. Okay, that's where Microsoft made their millions in that one deal. Now there is a really funny part of that deal. Anybody know the kind of the problem with that little arrangement? Go ahead. Yeah, they didn't have an operating system. So he just made a deal licensing an operating system to IBM every single time IBM sold a computer. And Microsoft didn't have an operating system. So now they have, it's like a chicken or the egg problem. Now they gotta go run out and find an OS that they can license to IBM to fulfill this deal that they just made. So they went out, and I think they ended up getting DOS for something like $50,000 or something like that. Pretty good deal. It made a couple more cents than that on that. And you look at the evolution of Microsoft Windows. So their early operating system was called DOS, and then Windows 3.1 was based on top of DOS. It was a graphic user interface, and Windows 95, Windows 98, and then you had the NT stuff, Windows 4. Here, if I just draw the picture real quick in our last couple of minutes. We have DOS. Then we have, I'll just hit the highlight ones. Windows 3.1. And you had Windows NT 3.51. I'm going to color code this guy. We're going to make him yellow here. This is actually their business operating system. So Windows 3.1 was still based on top of DOS. Windows NT was based on top of something called the NT kernel, a new operating system that Microsoft actually did make. All right. So then through here, our evolution went Windows 3.1 to Windows 95. And then we had Windows NT 4, which gave you the Windows 95 user interface on top of the NT kernel. Then we had Windows 98, and this is where things got a little hairy at Best Buy, is you would be at the shelves of Best Buy and you would see, this is back when they sold software on the shelves, something called Windows 2000, thinking that's the upgrade to Windows 98, and it was not. It was the upgrade to Windows NT 4. So people would buy Windows 2000, great operating system. In fact, you could probably find some places still running Windows 2000 today. But it was their business operating system, so it didn't have any of the drivers for your joysticks or your graphics cards or anything like that. So all your software at home for your kids' games and stuff didn't work anymore. Then we had the demise here of their consumer line, Windows Millennium. So we'll call this guy where it died. And I'll just quickly finish this up. And that's where these guys came together in Windows XP. So Windows XP has the NT kernel, the stability of their business kernel, with the driver support of their consumer line. All right, so then from here we go to Windows 7, Windows 10, and Vista will kind of just put a little zigzag. Go ahead. It's right after Windows XP. And Vista was an important start. Vista was not a bad operating system. It was an inconvenient operating system. It gave you too much headache. All right, so I think there's another paper due on Monday, right? What's that one on? Oh yeah, comparison Python 2 versus Python 3. All right, we'll keep trucking on Monday, hopefully get through this history, and then we'll be ready to start getting into our first Python programming stuff. All right? I will see everybody on Monday.